Let me tell you a story where we bring to life a robot inspired from science fiction. It was some time ago, in the mid-1940s, when Isaac Asimov, a great pioneer in the field of science fiction, first conceptualized the mutual existence of humans and robots. This summer, the students at TU Dresden performed some very interesting work. Team Nanobot created a nanomolecular robot designed to work and assemble in a modular fashion. This nano-robot has been built using self-functioning building blocks. Let us now learn more about these individual building blocks in detail. A liposome is a hollow sphere composed of a phospholipid bilayer. Due to the hydrophobic interactions of the fatty acid tails, the individual phospholipids self-assemble in a single-step process and form well-defined liposomes. Dynabead is a magnetic particle made up of silicon core that plays a central role in creating the nanorover. It is responsible not only for controlled motion in the presence of a rotating three-dimensional magnetic field, but is also used for sample purification in later stages. Finally, DNA origami techniques were used to fold 6 helix bundles. Their robustness and programmable design makes them a perfect candidate to connect different components. The individual components from various fields of science can be strategically combined. This is how the nanorover was formed. Let me show you what the nanorover can do. Liposomes can be used to encapsulate both water-soluble and fat-soluble drugs. These drugs can later be released once the nanorover reaches its targeted destination. Specifically designed peptide sequences attached to a template such as a quantum dot are capable of bursting the liposome and releasing its contents. Upon chemical modification, these liposome-bursting peptides can also serve as cell-penetrating peptides. This allows for the selective targeting of harmful molecules and their consequent uptake into the liposome. By changing the magnetic field parameters, several dynabeads can be assembled in an array, forming a supramolecular assembly of dynabeads. Thus, a mechanosensing device can be designed for a biological system by interpreting the interactions of the beads in changing environments. Let's go back to our story. Wouldn't you say we have entered a new era of robotics?